Algebra Unit 6, Lesson 7, Notes 10, Systems of Inequalities. Remember, when we're graphing inequalities, basically a system of inequalities is just two inequalities graphed on the same set of axes. For a dashed line, we would use the less than or greater than symbol. For a solid line, it'd be less than or equal to and greater than or equal to. We shade above when it's greater than or equal to. And we shade below for less than and less than or equal to. A system of inequalities is a set of two or more inequalities with the same variables. The solution to a system of inequalities is where the shaded regions cross. Write an S in that region. Graph the following systems of inequalities and answer any questions that follow. So I'm going to go ahead and skip to letter B, and then you can go back and do letter A. The first thing we need to do is make sure that our inequalities are in slope-intercept form, and it looks like we have to change both of these. So that's the first thing I'm going to do. I'll start with the second one here. I'm going to subtract x from both sides, and I get negative y is greater than or equal to negative x plus 1. I need to divide by negative 1, and remember, when we multiply or divide by a negative with inequalities, we flip the symbol. So it becomes less than or equal to positive x minus 1. Our slope here is 1 over 1, and our y-intercept is negative 1. If we take a look at our symbol is less than or equal to. Because of this bar down here, that equal to, I know it's a solid line. So I'll jot that down. I know it's solid. And I also know that I shade down. Y is less than the expression x minus 1, so we shade down. Let's take a look at this first equation, or inequality. Y plus 2x greater than negative 8. Going to subtract 2x from both sides. And we get y is greater than negative 2x minus 8. The slope is negative 2 over 1. The y-intercept is negative 8. It is going to be a dotted or dashed line because I have a greater than symbol, not the equal to part. And I know y is greater than, so I shade up. So I'm going to zoom in on my graph. You won't be able to see my inequalities, so make sure you check back on yours if you have any questions. Let's start by graphing the red inequality first. Okay, the red inequality is y is less than or equal to x minus 1. So my y-intercept is at negative 1. And it is up 1, right 1. So plot some points here. I like to go end to end so that when I use my ruler, and please use a ruler, when I use my ruler, it makes it the best possible line, the most accurate. I also know this is a solid line, so that's easy to do. It must have arrows on both sides. And make sure you label it. Y less than or equal to x minus 1. Okay, I also know that I shade down. So whenever I shade up or down, I always look at my y-intercept. My y-intercept is here, and I'm shading down. So I'm going to shade everything underneath that. Okay, first inequality done. Next one, I have a y-intercept of negative 8. And the slope is down to right 1. this up a little, down to right 1. I'm going to go in the opposite way now, up to left 1. Now with inequalities, I'm not looking for them to intersect at a point. I just am looking where their shaded regions intersect. Okay, this one is a dotted line. Don't know if it's going to let me draw a dotted line. Let's see here. Okay. I don't think... Okay, it's not going to let me draw a dotted line, so let me actually go back here. I'll just trace over and then erase that line. So when you're drawing your dotted line, definitely still use your ruler. Definitely have arrows on the end. Just going to move that right out of here. Just get that out of the way. Just ignore that there. Okay. And we're going to label this one as y is greater than negative 2x minus 8. Again, I'm going to look where my y-intercept is. I know it's greater, so I shade up. And the solution to this is where your shaded regions intersect. And we are going to label that with a big S. That is your solution set. So any point that's in that solution, in that area, that shaded area in that solution is part of the solution. Now, if it winds up on a solid line, it's still part of the solution. However, if a point lines up on any dotted line, it is not part of the solution because the line, if it's dotted, does not include it. So now we need to determine whether or not each point is in the solution set. So negative 2, 0. Negative 2, 0 is here. It's not in the solution set. Negative 4, negative 7. Also not in the solution set. 6, negative 3. Definitely is. It's where the blue and the red lines intersect here. So this one definitely is. Negative 5, positive 4. Nope. 2, 1. Now, it's on the line. It's on the boundary here. Because it's a solid line, yes, it's part of the solution. That solid line borders the shaded region, the solution set. So I'm going to say yes, it is. Again, because it's a solid line. And negative 2, negative 3. Now this one, it's on that solid line. It isn't quite touching the dotted line. It's part of the solution set, the shaded area here. So yes, this one is also part of the solution. Okay, let's jump to D. Remember, when we have equations or inequalities that are y equals a constant and or x equals a constant, they're either vertical or horizontal lines. So for letter D, we have both scenarios. We have y is greater than or equal to 3, which means it's a horizontal line crossing at y equals 3. And x is less than or equal to negative 4, which is going to be a vertical line crossing the x-axis at negative 4. They're both equal to, so I know they're both going to be solid. So let's start with this first one. It's solid, and I know I shade up. And the second one is also solid, and I shade down. Okay. So at y equals 3, I'm going to draw a horizontal line. Going to make sure I put my arrows. and I'm going to label. And I know I shade up. Y is less than or equal to -4. Vertical line at x equals -4. Again, make sure you have your arrows. Now this one says shade down, but I don't really have a down because it's a vertical line. But remember, I want x values less than -4. So the x values less than -4 are left. We have a nice intersection here. And we have two solid lines. Oh, I forgot to label. X less than or equal to -4. We have two solid lines here, so if something does end up on the line in the shaded region, we're good to go. So -5, 6. -5, 6 is up here. 1, 7. It's over here in the positive. It's definitely not. -6, 3. It's on the solid line with bordering that shaded region, so yes. -7, -2 is going to be down here, which is a no. -4, 0. It's right here, also a no. And -4, 3. It is on two solid lines, and it's at the corner of that shaded area, so that is a yes. Letter E. Our first inequality is solved for us already, so I know this is going to be a dotted line, and y is less than, so it's shaded down. Our y-intercept is 2/1. I'm sorry, our slope is 2/1. Our y-intercept is -4. The second inequality, to get y by itself, I'm going to divide by 4. Y is greater than or equal to 2x plus 1. I know it's a solid line because of that greater than or equal to. And y is greater than, so I shade up. My slope is 2/1, and the y-intercept is +1. Okay, let's look at the red one first. Y-intercept is -4. And I'm going up to right one. Again, use a ruler. It is dotted. So I'm going to, due to the limitations of this program, I'm going to draw it in and then do the dotted afterwards. You can always draw it in with pencil and erase spots here and there, or you can just draw in the dashes, which is what I usually tend to do. Oops. Just get that out of the way. My dashes are a little off here, especially these ones. Okay. And I shade down. And this is y is less than 2x minus 4. The second inequality, I start at +1. And I go up to right one. Now you should notice something as you're plotting this. Maybe you even noticed beforehand. Okay, I'm going to draw a solid line, so that'll be a little easier. Arrows and label. And this one shades up. Now you should have noticed that the lines are parallel, And in this case, they shade in opposite directions, so I actually have no solution. Now, they can't, just because they have the same slope in inequalities doesn't mean there's no solution. For example, if it would have shaded down, the blue one, if I shaded down, all of this would be a solution. Similarly, if the red one shaded up, all of this would be a solution. So with inequalities, it's not necessarily no solution if they have the same slope. It all depends on the shading as well. Okay, because there's no solution, we don't have any points to determine if they're on or off the solution set because there are none. On letter F, there are 3 inequalities. I want you to give it a try. Maybe use colored pencils or highlighters to help you with the shading. It gets a little busy when you have 3 inequalities on there, but go ahead and give it a try and see what you come up with.